We are going to start now third chapter of class 10th mathematics. It is pair of linear equations in two variables. So linear equation we already know. It is, we are saying, when we are talking about the equation of the form ax plus b is equal to 0, this is linear equation in one variable. The variable over here, this is x. These a and b, these are the constant terms. So linear means over here the power of x, it is 1. So this is linear equation in one variable. Now we are talking about linear equation in two variables. So it is ax plus by plus c is equal to 0. So we have two variables over here. One is the variable x and second is the variable y over here. So some examples of the linear equation in two variables are given. First is this 3x plus 4y plus 2 is equal to 0. In the second equation again x and y, these are the two variables. Third equation, this x and y, these are the two variables. Now if we look at this equation over here, it is root 2x minus root 3 y is equal to 0. We are saying both these x and y, they have the power 1, and these constant terms are basically we are saying these constant terms we are talking about, these are basically the real number. These can be the real numbers. So we are saying this is the definition. So these are some of the examples of linear equations in two variables. Now next thing we have is the solution of the linear equation. Solution means we are talking about those values of x and y. Suppose we are saying the value of x is equal to alpha and y is equal to beta. If we substitute in this equation, means in place of x we are writing it is a alpha plus b beta plus c. If it satisfies this equation, these are x and y, these are the variables. We are substituting some real values alpha and beta in this equation, and we are saying it is these two values alpha and beta of x and y, they satisfy this equation, then alpha and beta is called the solution. X is equal to alpha and y is equal to beta is called the solution of the equation. So next an example is given to us that an equation is given, it is 5x minus 3y equal to 9. We have to check whether x is equal to 3, y is equal to 2 is a solution of this equation or not. So what we are going to do, in place of x we will substitute 3, in place of y we will substitute 2. So we will get it is 5 into 3 minus 3 into 2, that is equal to 15 minus 6. We are talking about the LHS, and this is equal to 9, and that is equal to RHS. LHS means left hand side and this is right hand side. So this part of the equation we are saying this is the left hand side of the equation, and this part we are saying this is the right hand side of the equation. So what we get is, when we substitute these values of x and y, we get the answer is 9, and that is equal to the RHS. Next we have simultaneous linear equations in two variables. So first of all, we have seen the definition of linear equations in two variables. So suppose I am talking about two equations over here. Say it is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. These are two equations in two linear equations in two variables. Variable means this x and y, these are the two variables, and these are the two equations we are talking about. This is equation number 1 we are saying, and this is equation number 2. So these are the constants over here, a1, a2, b1, b2, these are the constants over here. So simultaneous equation means we are talking about these two equations, these are given together. It means when we are talking about the solution of the equation 1, suppose I am talking about equation 1, solution of equation 1, say it is alpha beta. So it means it is a1 alpha plus b1 beta, that is equal to c1. This is a solution of equation 1. Suppose now if this alpha beta is also a solution of the second equation we are talking about, it means a2 alpha plus b2 beta, that is equal to c2. It is satisfied over here. Then we are saying that this pair we have, this is the solution of both these equations, and these two equations, these are called the pair of linear equations in two variables. So it is given that two linear equations, this word simultaneous is there. Simultaneous means that whatever value of alpha beta we have, it is satisfied simultaneously for both these equations. So it is two linear equations in two unknowns x and y are said to form a system of simultaneous linear equations if each of them is satisfied by the same pair of values of x and y. We are saying this alpha and beta, these are the solution for both these pairs. Then these equations, these are called the simultaneous linear equations. So we are considering the system of equations, say x plus y is equal to 10, and second we are considering it is x minus y is equal to 2, and we are talking about a solution x is equal to 6 and y is equal to 4. So if we put the value in both these equations, we are saying 6 plus 4, that is equal to 10, and 6 minus 4, that is equal to 2. It means what we are saying over here is this is x plus y, that is equal to 10, and this is x minus y, that is equal to 2. So we are saying that this value x is equal to 6 and y is equal to 4, these values x equal to 6 and y is equal to 4, they satisfy both these equations simultaneously. So we are saying the given equation form a system of linear equations in x and y. Now next thing we have to do is we are talking about the solution of a given system of two simultaneous linear equations. So there are different methods. So first of all, we are talking about how to verify whether the given value is the solution. So first question we have over here, we are talking about this first question over here. We are saying show that x is equal to 5 and y is equal to 2 is a solution of the system of equation. This is one equation that is given to you, and this is second linear equation that is given. So what we have to do is we have to write in place of x we will write 5, in place of 5 we will write y, we will write 2. So we are talking about these are the two equations, we have marked them over here, that this is the equation number 1, 2x plus 3y is equal to 16. This is the equation number 2 we are saying. When we are talking about equation number 1, we are solving first the LHS part, left hand side part means we are talking about 2x plus 3y. The value of x that we have to substitute, it is this 5 over here. So we have substituted in place of x, we have substituted 5. In place of y, we have substituted 2. So what we get is, we are writing it is 2 into x is 5 plus 3 into y is 2. This is the value of left hand side of the equation, and the answer we will get it is 16, and that is equal to RHS of this equation number 1. Next we are talking about the second equation. For second equation we are talking about LHS. So LHS is x minus 2y. So x is 5 and 2 into y is 2. This is the value of x, this is the value of y. The answer we will get it is equal to 1, and that is equal to RHS of equation number 2. This we are saying this is RHS of equation number 2. So we are saying that x is equal to 5 and y is equal to 2 satisfies both the equations 1 and 2. So we are saying that x is equal to 5 and y is equal to 2 is the solution of the given system of equations. These are the solutions over here. Now next question we have to show that x is equal to 3 and y is equal to 2 is not a solution of the equations. These are the two equations given to us. First equation we are saying it is 3x minus 2y is equal to 5. Second is 2x plus y is equal to 7. This is equation number 2 we are talking about. So if we substitute this value in the first equation, We are saying its answer is, when we are substituting this value over here, we are saying it is 3 into 3 minus 2 into 2. This is the LHS of equation number 1, and the answer that we will get it is 5, and that is equal to RHS. When we are talking about this equation over here, it is 2 into 3 plus 2. The answer we get it is 8, and this is not equal to RHS of equation number 2 when we are talking about equation 2. So we are saying that x is equal to 3 and y is equal to 2 is not a solution of this system. Now it is important to note over here that x is equal to 3 and y is equal to 2 is a solution of x. We are talking about 3x minus 2y is equal to 5. It is a solution of this equation, but not a solution of the second equation we are talking about. It is 2x plus y is equal to 7. So it means when we are talking about this equation over here, it will have infinite solutions. We are saying that if one of the solution that we are talking about, this is one of the solutions over here, and this is not the solution of this equation over here, it means this is not the solution of the simultaneous equation. It may have some other solution. We are saying it has infinite solutions. Basically it has infinite solutions, but this is not the solution of this simultaneous, these two simultaneous linear equations. Now suppose in place of this we are saying x plus y equal to 1, and second we are saying x minus y is equal to 1. So these are the two equations given to us. I am explaining again what is the meaning of this simultaneous over here. Suppose I am talking about the first equation. We are saying x is equal to 1 minus y. So if I put y is equal to 0, I get an answer that is x is equal to 1. In this equation I am talking about, if I put y is 0, we get x is equal to 1. From this equation I am saying x is equal to 1 plus y. If I put y is equal to 0, I get x is equal to 1. So what we get from this is that x is equal to 1 and y is equal to 0 is a solution of simultaneous equation, system of equation this. Now suppose we are talking about, we have substituted y is equal to 1. So when we substitute y is equal to 1, we get x is equal to 0. When we substitute y is equal to 1, we get x is equal to 2. Now look at these two values over here. For y is equal to 1, x is equal to 0. For y is equal to 1, x is equal to 2. So it means when we are talking about this solution over here, that 0 comma 1 is solution of 1. I am writing this is equation number 1, but it is not solution of 2. Then 2 comma 1 is a solution of 2, but it is not a solution of 1. So when we are talking about the single equations over here, these all are the solutions over here. There are infinitely many solutions. You can substitute different values of y over here and you will get different values of x, or you can substitute different values of x to obtain different values of y. But when we are talking about the simultaneous equation, then we are saying we are talking about all the common solution. It may have infinite solution, but we are talking about the common solution of both these equations, that those solutions which satisfy both these equations. Next we are talking about the consistent and inconsistent system of linear equations. So consistent means any system of equations which have at least one solution. At least one solution means there are two cases. Either they have a unique solution. Unique means one solution we are talking about. Or second case is they will have infinitely many solutions. These are the two cases we have for the term consistent. Inconsistent means the system has no solution at all, that no value is satisfying that relation. So as an example, this system is given over here that x plus y is equal to 3 and 2x plus y is equal to 7. It means we are interested in those values of x for which sum of x and y, for which x plus y is 3 and x plus y is 7 by 2. We will see more examples in our next slides, that how we can find whether the system has no solution, and what is, it will be more clear to you that what is the meaning over here. But from this example, how we can see, we are talking about, we are interested in those values of x for which x plus y is 3. It means value of y we have, it is 3 minus x. From this we are saying we are interested in those values of x for which x plus y is 7 by 2. It means value of y we have, it is 7 by 2 minus x. Now if I substitute some value of x, say I am substituting any value of x, say alpha, then the value of y I will have, it is 3 minus alpha. From this y is 7 by 2 minus alpha. Now look at these two values. We are saying the system will have solution if both these answer they are equal. Both these answer they are equal means that 3 minus alpha should be equal to 7 by 2 minus alpha. This gets cancelled, so what we get is 3 is equal to 7 by 2. Why I am saying so? We are saying these are the simultaneous equation given to us. We are supposing any number x is equal to alpha, it satisfies both these values. Corresponding to it, we have to find the value of y which satisfies both these values. We are saying from the first equation the value of y we have, it is 3 minus alpha. From the second equation we have value of y is 7 by 2 minus alpha. If such value exists, we suppose that such value exists, then we are arriving at a contradiction that 3 is equal to 7 by 2, and this thing is not possible. It means what we are assuming over here, that it is consistent. This is wrong, that this system cannot be consistent. It means this system has no real solution, or we are saying it has no solution. Now next is, we are going to talk about the first method of solving the system of linear equations, and the first method we are going to talk about, it is the graphical method. So we are going to draw the graph for both these equations, and we will see whether they have some solution or not. Now suppose we are given two linear equations. One is a1x plus b1y plus c1 is equal to 0. This is equation number 1. Second is a2x plus b2y plus c2 is equal to 0. This is equation number 2. We plot the graph of both these equations. We know how we plot the graph. We substitute different values of x and obtain different values of y. We construct a table like this, that corresponding to different values of x, we will find different values of y. We will plot the graph of this first equation. Similarly, we will plot the graph of this second equation. Both these will be the straight lines. This thing we know, these are the linear equations in two variables, and their graphs will be the straight lines. Now three cases are there. First is, the two lines we are obtaining from this, we are naming them as L1 and L2. Now case 1 we are talking about when line L1 and L2 intersect at a point. Both these lines, these are intersecting at a point. It is shown in this figure that whatever the equation is, we have drawn this line L1 corresponding to it. This is the line L2 corresponding to the second points. The point where they are intersecting, we are calling that point as P alpha beta, and we are saying this point, this alpha, x is equal to alpha and y is equal to beta, is the solution of the simultaneous linear equation. And this, when they are intersecting at a point, this kind of solution, this is called unique solution. That is, they have just one solution, that is x is equal to alpha and y is equal to beta. This is the solution of the equation, and this is the consistent system. And inconsistent, we are saying we have two of options, one is unique and one is infinite solution, and this system has unique solution. X is equal to alpha and y is equal to beta. Now the second case is that the lines L1 and L2 that we are obtaining over here, these are the two lines we are talking about, they are coincident. That means they represent both the equation, they represent the same line over here. We are saying this is the line L1 and this is also the line for the equation, second equation. Both these, they are representing the same line. So in this case we are saying all the points lying on this line over here, all these points. I'm talking about this point over here, this point over here. This is some point, say alpha 1, beta 1. This is some point alpha 2, beta 2. All these points, these are the solutions. So how many points we have? It is infinite number of points we can find. So it has infinitely many solutions. So this is also a consistent system and it has infinitely many solutions. If the graph of the both equations they coincide, then it has infinitely many solutions. Now the third case is that we have obtained two lines. One is the line L1 and one is the line L2, and both these lines, these are parallel to each other. This is the line L1, this is the line L2, and both these lines, these are parallel to each other. Both these lines are parallel to each other, so they are not intersecting at any point. So in this case we are saying it has no solution, and the case of no solution is also known as inconsistent. So the graph looks like this, that when we draw the equations, this L1 line is there, this L2 line is there, and they are not intersecting at any point. So we look at some examples over here. So first is solve graphically the system of linear equations x plus 2y is equal to 3, and second is 4x plus 3y is equal to. So we have to draw both these lines. So to draw this line, we are talking about the first equation over here. It is x plus 2y is equal to 3. So from this equation we can write that 2y is equal to 3 minus x. So we get y is equal to 3 minus x by 2. So if we substitute different values of x over here, we are substituting x is equal to say 1. We get y is equal to 3 minus 1 by 2. And the value we get, it is 1. If we substitute x is equal to minus 1, we get y is equal to 3 plus 1 by 2, that is equal to 2. If we substitute x is equal to minus 3, we get y is equal to 3 plus 3 by 2, that is equal to 3. First thing, something that we are going to note over here, a few things are there. First is 2 points are sufficient to draw a line. So it might be sufficient for you that if we are talking about that if we find only these 2 points, we are saying suppose I have calculated the point 1 comma 1 and second I am talking about minus 1 comma 2. These 2 points, these are sufficient to draw a line. We know that it is a straight line. So what you are going to do is, on the graph paper you are going to mark the point 1 comma 1, then you are going to mark the point minus 1 comma 2. This is the point 1 comma 1 and this is the point minus 1 comma 2. You will join both these points and you will get the straight line. But we are using 3 points over here because when we are using the third point, it is minus 3 comma 3. It will be somewhere over here. It is minus 3 comma 3. It will help you check whether the line you are obtaining it is correct or not. Suppose when you have calculated the value, you in place of 2 you have calculated it is 1. Then what will happen? These 3 points, these will not be collinear. You will come to know that somewhere you have committed the mistake. So that is why we are using 3 points over here, so that you should be sure that whatever calculations you have done, they are correct. Second thing is how we are trying these points. We are saying we have substituted x is equal to 1. You can use any points over here. It is not necessary that you have to use 1, minus 1 and 3. Suppose in place of this I have used x is equal to 0. What I will get? I will get 3 by 2, that is equal to 1.5. So to avoid this kind of points, that I'm getting 1.5 over here. So to avoid these numbers over here, we are using something that makes these numbers as the integer values. We are talking about, we have chosen x in such a way that these numbers are the integer values. If suppose in place of -3 I have used -2, then what will happen? It is 3 plus 2 by 2, it will be 5 by 2, that is equal to 2.5. This value will be equal to 2.5. So again, it will be difficult to draw on the graph. You can use this point, it is not like this that you cannot use this point, you can use this point also. So but we generally try to make all these numbers, to find the numbers such that all these numbers, these are the integer values. Similarly, the second equation we have, it is, we are talking about, it is 4x plus 3y is equal to 2. When you find the value of y from this, you get it is 3y is equal to 2 minus 4x. The value of y you get, it is 3 minus 4x by 3. What we are going to do now, it is 2 minus 4x by 3. So when we look at this value over here, if suppose I substitute x is equal to 0, I will get the value of y as 2 by 3. We are less interested in this value. If we substitute x is equal to 1, we get the value is 2 minus 4 by 3. We are less interested in these kind of values. If we substitute x is equal to 2, what I will get is, it is 2 minus, I have substituted x is equal to 2. So it is 2 minus 8 by 3. So the answer you will get, it is minus 2. So we are saying for x is equal to 2, the value of over here we are getting it is minus 2. Next, if suppose I am talking about negative values over here, if I substitute minus 1, I will get 2 minus 4 into minus 1 by 3. So it is 2 plus 4 by 3, that is equal to 2. So the values that I have obtained for x is equal to minus 1, y is equal to 2. Similarly, for x is equal to minus 4, y is equal to 6. You can substitute the value in of x whatever you want, but just try to find some integer values so that it will not be difficult for you to locate the point on the graph. Now we have the values of x and y corresponding to both these equations. These are the values of x and y corresponding to both these equations that are given to us, and we are going to plot these points. So corresponding to first equation, we are having the point minus 3 comma 3. So minus 3 comma 3, this is the point over here, this is the point minus 3 comma 3 we are talking about, that corresponding to minus 3, this is over here and this is over here. We are saying this is the point minus 1, minus 2, minus 3. Over here it is 1, 2, 3. This is again minus 1, this is 1, 2, 3, 4. Like this we have the points over here. Next is minus 1 comma 2. So minus 1 comma 2, it is the point over here, and 1 comma 1, this is the point over here. These are the 3 points we are talking about corresponding to these 3 values. These are for the first equation. When we join all these points, we obtain the straight line like this. You will join using the scale and you will obtain this straight line over here. Next points we have, it is minus 4 comma 6. So minus 4 comma 6 is somewhere over here. I think this is point minus 4. This is 3, 4, 5 and 6. Next is minus 1 comma 2. Minus 1 comma 2 we have marked earlier also. And last point we have, it is 2 comma minus 2. When we join these points, we obtain this straight line over here. And both these lines, they are intersecting at this point B, that is, we are saying they are intersecting at the point B, that is minus 1 comma 2. So what we are saying is that the solution of this equation is x is equal to minus 1 and y is equal to 2. This is the solution of the given simultaneous linear equation. So it has a unique solution. What we have seen from this, that both these lines, these are intersecting at a point. So it means the system is consistent. We are saying the system is consistent, and inconsistent it has a unique solution, and the solution is given by this point, that is x is equal to -1 and y is equal to 2. Next is solve graphically the system of linear equations. These are the equations given. It is 4x minus 5y plus 16 is equal to 0, and second is 2x plus y minus 6 is equal to 0. So corresponding to this first equation, we are saying we can calculate the value of y, that is equal to 16 minus 4x over 5. Now we are interested in those values for which this 5 gets cancelled out and we get some integer answers over here, integer values over here. So what we are going to do is suppose I substitute the value of x is equal to -1. This value we are saying it is not minus sign over here, it is plus sign over here. So the value we are going to use it is +1. So corresponding to first +1, x is equal to +1, if we substitute, we get y is equal to 16 plus 4 by 5, that is equal to 20 by 5, that is equal to 4. So we are saying corresponding to 1, we are getting the value, it is 4. The next value we are saying the next multiple of 5 that we will get, if we substitute 2 over here, we will get 4 to the 8, and we will not get the multiple of 5. We substitute 3 over here, it is 3 4 the 12, we will not get the multiple of 5. We try 4, we try 5, we try 6. When we multiplied with 6, we get this value will become 24, and it is plus 16, and the answer that you will get, it is 40 by 5, that is equal to 8. So we are saying for x is equal to 5, for x is equal to 6, we get y is equal to 8. And similarly, we can substitute the value x is equal to -4 and we will get y is equal to 0. Now in the second case, we are having the equation, it is 2x plus y minus 6 equal to 0. So what we get from this is that 2, we are finding the value of y, it is 6 minus 2x. So there is nothing 1 over here in the denominator, so we are not much worried about what values of x we have to substitute. So we are using the values 0, 2 and 3. You can use 0, 1, 2, you can use 0, -1, 1, any 3 values you can use. And when you will substitute these values in this equation, you will get the values of x and y. These are the values we are obtaining over here. So we have obtained these values over here, that for these values of x we have these values of y over here, and for these values of x we have values of y over here, and we have plotted these points. So these are the points we are talking about. This is the point -4, 0. You have to mark the points on x-axis and y-axis. These are 1, 2, 3, 4. This is -1, -2, -3, -4, and over here it is 1, 2, 3, 4, like this. You will get the points over here in this direction. So when you mark these points, the next point we have first is -4, 0, next is 1, 4. So 1, 4 point we have marked over here, and next point we have it is 6, 8. This is the point C we are talking about. Similarly, the next points we are talking about, it is 0, 6. So 0, 6, this is the point 0, 6. Next is 2, 2. This is the point 2, 2. And next point we have it is 3, 0. This is the point 3, 0. So if we join these points, we get these two lines over here. This is one line we have obtained, and this is the second line we have obtained. These are the two lines that we have obtained over here, and both these lines, they are intersecting at this point B. So what this represents? This means that the system of equation, they are consistent and they have unique solution, and that solution is x is equal to 1 and y is equal to 4. This is the solution of this consistent system. Now next, again a system is given to us. It is 4x minus 5y is equal to 20, and second is 3x plus 5 y is equal to minus 15. So corresponding to both these equations, we have calculated the values of x and y. These are the values of x that we have calculated, x and y corresponding to the first equation. Similarly, as we have discussed earlier also, we have calculated the values of y corresponding to the x corresponding to the second equation over here. These are shown in our next slide. These calculations, these are shown over here. You can try at your home that how from this equation you will calculate y is equal to 4x minus 20 over 5. For different values of x, we have calculated the values of y. For x is equal to 0, 2, 5, we have calculated the values of y over here. You can use different values over here to calculate these answers. Similarly, in second case, we have calculated y is equal to 15 minus 3x over 5. This is the value of y we have obtained. Then we have substituted different values of x in this equation and we have obtained the values of y over here. Now, next thing we have to do is we have to plot both these points x, y corresponding to the first equation. These are the points corresponding x, y corresponding to the second equation. We have plotted these points on this graph and we have obtained two lines over here. These are the two lines that are shown over here. These are the two lines we are talking about. These are the points that we have marked. This is minus 5, 6, 0, 3, 5, 0. This is minus 4, 0, 2, 2, minus 2.4 and 5, 0. Both these equations, they are intersecting at this point. It means both these equations, these are consistent. They have unique solution and solution is x is equal to 5 and y is equal to 0. This is the unique solution over here. Now in this question we have to find the vertices of the triangle formed by the line representing the above equation and the y-axis. So we are saying these are the two lines. Now we are talking about the y-axis. This is the y-axis that we have. So we are having a triangle over here. We are talking about this triangle QAC. So in this question we are given that we have to write the vertices of the triangle QAC. So Q has the point 0, 3, A has the point 0, minus 4 and C has the point 5, 0. So these are the vertices of the required triangle. So the procedure is same, that whatever the equations are given to you, you have to find the values of x and y. That is, first of all we have to draw those lines. Then you have, if those lines they are intersecting at some point, we are saying that at one point we are saying, then we say that the system is consistent and it has unique solution. And as in this question it is being asked that find the vertices of the triangle. So we have shown the vertices of that required triangle. Now the next question we have is solve the following system of equations graphically. It is 3x plus 2y minus 11 is equal to 0 and 2x minus 3y plus 10 is equal to 0. So again for the first equation we have y is equal to 11 minus 3x by 2. We have substituted different values of x in this equation to obtain different values of y. We have substituted x is equal to minus 1. You will get 11 minus 3 into minus 1 by 2. When you will substitute x is equal to 1, you will get 3 into 1 by 2. When you will substitute 3, it is 3 into 3 by 2. So the answers in this case, it is 7, this is 4 and this is 1. So these are the values represented over here in this table, that corresponding to this equation 3x plus 2y minus 11 is equal to 0. We have for these values of x, we have these values of y over here. Next, similarly for the second equation we have, it is x 2x minus 3y plus 10 is equal to 0. We get y is equal to 2x plus 10 over 3. We have substituted different values of x. X is equal to minus 2, x is equal to 1 and x is equal to 4 to obtain different values of y. Y is equal to 2, y is equal to 6 and y is equal to 4. You can substitute these values in over here and you can get these answers. So we have obtained this table over here, that x corresponding to x, we have these values of y. Now what we have to do is we have to plot these points on the graph. So we are talking about the first point we have, it is minus 1 comma 7. So minus 1 comma 7 is over here. This is the point A we have marked over here. Next is 1 comma 4. 1 comma 4 is the point over here. This is the point B we are talking about. And next point we have, it is 3 comma 1. This is the point 3 comma 1. 3 comma 1 means on x axis it is 3 and on y axis it is 1. Similarly, this A point when we are talking about, this is minus 1 and corresponding to this it is 7 over here. So you have to mark these points, minus 3, minus 4 like this, then 1, 2, 3 like this. In similarly over here we will have minus 1, this is 7, somewhere over here it will be 6, then it will be 5 like this. You have to mark all these points. So we have obtained these points corresponding to first equation. Similarly for the second equation, it is minus 2 comma 2. This is the point minus 2 comma 2. Then it is 1 comma 4 and the last point we have, it is 4 comma 6. So we join these points and we draw these straight. This is the straight line we have drawn for this point and this is the straight line we are drawing for this. We have drawn these two straight lines. Again, this system of equations we have, it is consistent and has unique solution. But what we have to find in this question is we have to shade the region bounded by these lines and the x-axis. Now what is x-axis over here? X-axis is this axis. We are talking about two lines we have. This is one line, this is the second line, this is the x-axis. To shade the region between these two lines and x-axis, so this is the required region. This is this region we are talking about. This is the required region. This is the required region. Now next, these two equations, these are given to us. One equation is 3x plus y minus 11 is equal to 0 and second equation is x minus y minus 1 is equal to 0. These are the two equations that are given to us. We have to shade the region bounded by these lines and the y-axis. Next, we have to find the coordinates of the points where the graph lines cut the y-axis. So again, same procedure is there. We are talking about this equation is given to us. We have calculated y is equal to 11 minus 3x. For different values of x, we have calculated different values of y. For x is equal to 2, y is equal to 5. For x is equal to 3, y is equal to 2. X equal to 5, y is equal to 4. We are substituting these values of x in this equation to find the values of y. Similarly, for the second equation, we are saying y is equal to, when we substitute this value, it is x minus 1. We have substituted now x is equal to minus 3, x is equal to 3 and x is equal to 0. And values of y corresponding to it, it is minus 4. For x is equal to 0, it is y is equal to minus 1. For x is equal to 3, it is y is equal to 2. These are the values of y corresponding to x that we have obtained, and these are the values we have shown over here, that for first equation these are the values, for the second equation for x and y values, these are the values over here. So you can substitute different values and you will get different values of x, for you will get different values of y. So there are basically infinite solutions for all these equations. But when we are talking about the simultaneous equation over here, we have plotted both the lines for both these equations. So first point we have over here, it is 2 comma 5. So 2 comma 5, this is the point we have marked. Then it is 3 comma 2 and last point we have, it is 5 comma minus 4. This is corresponding to the first equation. Corresponding to the second equation, we have the points minus 3 comma minus 4, 0 comma minus 1 and 3 comma minus 2. These are 3 points we have. When we join these 3 points, we obtain, this is equation, this is the line corresponding to the equation 2 and this is the line corresponding to the equation 1. This region we are talking about, this is the required region. Required region means the region now we require, it should be between these two lines and the y-axis. This is our y-axis. So this region over here, this is the required region we are talking about. Next we have to tell the points where these lines they intersect with the we have to tell the points where these lines they are cutting the y-axis. So to find this point over here R, what we are going to do in this equation, in the first equation we are talking about, now the equation of this line we are talking about this line over here, this line we are talking about, its equation is 3x plus y is equal to 11. So we get y is equal to 11 minus 3x. If I substitute x is equal to 0, I will get y is equal to 11. So x is equal to 0 means this point we are talking about, and y is equal to 11 is this point. So we obtain this point R over here. We are talking about this point R over here. This is 0, 11. This is the point R, and this is the point where this line is intersecting the y-axis. Similarly, this point Q is there. It is 0, minus 1. This is the point Q, and this is the point where this second line, this is intersecting the y-axis. So these are the 2 points that we have to find. That Q point is 0, minus 1, and R is 0, 11. These are the 2 points that we have to find. Now next question we have, it is we are given 2 equations. One is 3x minus y is equal to 2, and second is 9x minus 3y is equal to 6. And we have to show graphically that the system of equations has infinite many solution. Both these equations, they have infinite many. This system, simultaneous system, has infinitely many solutions. So if we look at this first equation over here, we can write it is y is equal to 3x minus 2. So if we put x is equal to minus 1, we get y is equal to minus 5. We put x is equal to 0, we get y is equal to minus 2. We put x is equal to 2, we get y is equal to 4. When we are talking about this second equation over here, from this equation we are saying we have 3y is equal to 9x minus 6. So we get y is equal to 3 common. It is 3x minus 2 over 3. These two gets cancelled, and we are saying it is 3x minus 2. Values of y we have, it is 3x minus 2. So one thing is clear to us, that both these equations, these are actually same. So in place of finding these points, at finding the values of y at this point, suppose we are finding, you can use these same points also to say this thing, that both these they represent the same line. But in place of this, suppose I am writing x is equal to, say I am using the point 1, 2 and minus 2. We are using the point x is equal to 1, minus 2 and 2, and I will obtain the values of y over here for these values. We are saying both these equations, these are same. These points are sufficient for both these equations, but just for the understanding purpose we are using these different points over here. So what we get is, we get two system of points. One is, we are talking about the point x is equal to minus 1, y is equal to minus 5, x is equal to 0, y is equal to minus 2, for x is equal to 2, y is equal to 4. The second pairs we are obtaining, it is minus 2 and minus 8, 1, 1, 2 and 4. When we plot all these points on the graph, what we obtain is the points corresponding to this equation over here. It is minus 1, comma minus 5, then 0, comma minus 2, and then 2, comma 4. Next points we have, it is minus 2, comma minus 8, then it is 1, comma 1, and last point we have again, it is 2, comma 4. So when we draw the line over here, we obtain this line, this PBQC line we are talking about. So we are saying this line is corresponding to both these equations. So any point on this line, any point on this line is a solution of simultaneous system that is given to us. So any point on this line, that is the solution of that simultaneous system that is given to us. So how many points we have? We are saying we have infinitely many solutions. We will have infinitely many solutions. So we are saying this system is consistent and it has infinitely many solutions. Consistent was having two cases, one is unique and second is infinite, and this is the example of infinitely many solutions, because we are obtaining that both the lines we are talking about, the two equations were given to us and the line corresponding to both the equations, they are same. So this system has infinitely many solutions. Now next is show graphically that the system of linear equations, these are the equations given to us, one is 2x minus 3y is equal to 5 and second is 6y minus 4x is equal to 3. Both these systems, they are inconsistent, that is they have no solution. So again, the first step we have calculated the value of y from this equation. So the value of y we get, it is 2x minus 5 by 3. We can calculate the value of y from this equation. It is 3 minus 4x by, it is 3 plus 4x by 6. We have substituted different values of x. In this equation we have substituted x is equal to minus 2, x is equal to 1 and x is equal to 4. And we have obtained the values of y, it is minus 3, y is equal to minus 1 and y is equal to 1. Next, in this equation we are saying we have substituted different values of x. X is equal to minus 3, x is equal to 0 and x is equal to 3. And we have obtained the value of y is minus 3 by 2, y is 1 by 2 and y is 5 by 2. These are the values of y that we have obtained corresponding to this equation over here. So these are the points shown in this table over here, that corresponding to x is equal to minus 3, we have y is equal to minus 3 by 2. For x is equal to 0, we have y is equal to 1 by 2. And for x is equal to 3, we have y is equal to 5 by 2. When we plot these points on the graph, what we see is, the first point we have, it is minus 2 comma minus 3. This is the point A we are talking about. You will mark these points over here. It is minus 1, minus 2, minus 3. This is 1, 2, 3, 4, 5. These points we are talking about, these are 1. Then next it is 2, then somewhere 3. Similarly, we have these points over here. It is minus 1, then minus 2, then minus 3 and so on. These points are there. So when we are marking the point minus 2 comma minus 3, it is over here. Next we have minus 1 comma 1 comma minus 1 and next we have it is 4 comma 1. Now next point we have it is minus 3 comma minus 3 by 2. This point we are saying it is minus 3 comma minus 3 by 2. Next is 0 comma 1 by 2. This point Q we are saying it is 0 comma 1 by 2. And this point we are saying it is 3 comma 5 by 2. This point we are saying it is 3 comma 5 by 2. When we join all these 3 points, we obtain this line over here. This is the line corresponding to 2x minus 3y is equal to 5. This is the line corresponding to 6y minus 4x is equal to 3. And what we see is both these lines, these are parallel to each other. They do not intersect. It is written over here that they do not intersect even when they are produced infinitely. They will not intersect. So what we are saying, there is no point of intersection over here. It means the system has no solution, and such system is called inconsistent. When it has no solution, these kind of system, these are called inconsistent systems. Next is show graphically that the system of linear equations x minus y equal to 8 and 3x minus 3y is equal to 16. These are the two systems given to us. We have to show that they have no solution. So again, corresponding to both these, corresponding to the first we are writing y is equal to x minus 8. Corresponding to second we are writing y is equal to 3x minus 16 by 3. We substitute different values of x in this equation to obtain different values of y. Similarly, we are substituting different values of x in this equation to obtain different values of y. So in this case, you can solve these values over here. You can substitute these values of x that are shown over here, and you will obtain the points corresponding to the first equation. We have the point 3 comma minus 5. This is the point over here. Next is 4 comma minus 4. This is the point over here. And next is 5 comma minus 3. This is the point over here. Corresponding to the second equation, we have the point 3 comma minus 2.3. Next is 2 comma minus 3.3. Next is 0 comma minus 5 by 3. So when you will join these points, you will obtain a line over here. When you will join these points, you will obtain a line over here. This line you will obtain. And again, both these lines, these are parallel to each other. They have no point of intersection. It means they have no solution, and no solution is also called inconsistent. And this is what we have to prove, that the given system of linear equation, it has no solution, that is they are inconsistent.